Hello and welcome with a new lecture in material science and application in architecture. We will continue the our smart materials. In fact, we saw in the last session that we have different families of smart materials, including property changing smart materials. So these are smart materials that change their properties. They, for example, change their shape, or they change their color or optical properties. They can also change their adhesive properties. So we have first property changing smart materials. We have energy exchanging smart materials, and smart materials that exchange energy from one type of energy to another type of energy, like light emitting materials, electricity generating materials, and energy and other types of energy exchanging materials. And we also have the family of matter exchanging smart materials. In this lecture we will study in detail some smart materials that change their properties. Particularly, we will study thermostructive smart materials, we'll study electroactive smart materials, and we will study electrochromic smart materials. Here you will see that piezoelectric materials can be considered as property changing smart materials, and they change their properties according to what? So piezoelectric material can be considered as property changing smart materials, but they can be also considered energy exchanging smart materials. Why? In fact, piezoelectric materials, they are sensitive to mechanical stress, and so they give us electrical energy. مشان هيك سميناهم حطيناهم بالاlectricity generating smart materials, because they generate electricity based on mechanical stress, based on deformation, based on pressure, on compression. But also هن مش بس sensitive على deformation وبيعطونا electricity، هن كمان إذا عطيناهم electricity بيعملوا deformation. يعني هن بيشتغلوا in the two directions. بياخدوا mechanical stress بحلوها ل electricity, and they also convert the electricity, the electrical power, and they transform it to a mechanical deformation, and so they will be deformed. يعني they will change their shape according to the electrical power. مشان هيك piezoelectric materials can be considered as both as property changing smart materials and also as energy exchanging smart materials, and particularly electricity generating smart materials. Okay. Okay, we've done with piezoelectric materials. In the last session we saw what are photochromic materials, we saw what are thermochromic materials, and we saw what are photoluminescent materials, and we saw how piezoelectric material can generate electricity. So we'll start with now thermostructive smart materials. So these belong to the property changing smart materials. So they are of هلا thermostructive, piezoelectric, electroactive and chemostructive هيدول هن ضمن ال property changing smart materials which have the greatest interest in the field of architecture because they are available, because they have a long-term stability and for other reasons. What are thermostructive materials? So thermostructive materials change their shape or their dimension. They are able to change their shape or their dimensions because they are sensitive to thermal stimulus. They are sensitive to temperature changes. So we say that thermostructive smart materials react to ambient temperature changes. They are sensitive to temperature changes by reversibly changing their shape and or dimensions. In the field of architecture, the following thermostructive smart materials, among others, are currently of interest. We have different types of thermostructive materials, like what? Like thermal expansion materials or expansion materials. We have thermobimetals, we have shape memory alloys, we have shape memory polymers, and we have shape memory ceramics. كمان in the previous lecture we saw what are shape memory polymers. So we've studied them in the previous session, and today we will talk in details about shape memory alloys. Shape memory alloys, abbreviated as SMA, these materials possess the ability to regain to some previously defined shape or size when subjected to appropriate thermal changes. Again, they are sensitive to thermal changes. منشان هيك هن they belong to thermostructive materials because they are sensitive to thermal changes. So in fact, if this is the original shape of these shape memory alloys, so these are alloys, yani these are a combination of metals. This is the original shape of the shape memory alloy. We give it a certain deformation. We made a certain deformation on this on this material. So now it's deformed. Its shape changes. Now, if we apply a temperature change, or because of some change in the temperature, or by applying by making a heat transfer, for example, أو إذا أعطينا heat، إذا سخنا لها الماتيريال again at a certain temperature, it will regain its original shape. It will go back to its original shape, to the memorized shape إذا بتكون. That's why we call them shape memory alloys, because they have a certain shape, a certain memory of shape. So here we can see another illustrative image of shape memory alloys. If this is their original shape at ambient temperature, by applying a certain deformation, or by making a certain force on this material, it's it's under a certain deformation. Now by applying by giving thermal energy to this material, سخنة, it will go back to its initial shape. Where do we apply this, or where do we see shape memory alloys in architecture? In fact, they are of great importance in civil engineering because they help in seismic protection of buildings. So إذا في عنا seisms, the buildings عملوا are under certain deformation, if they are under certain forces، إذا بنرجع بنعطيهم heat بيرجعوا للinitial shape تبعيتهم. So it's this kind of material is very important for seismic protection. يعني in countries that are that have the tendency to have usual seisms, it's very beneficial to use shape memory alloys. They have great durability and reliability in the long term. Okay, materials and components in use include nickel titanium, that we call NiTi, nickel titanium. So this is an alloy, a combination of nickel and titanium. This alloy is also called nitinol. We can also use copper zinc aluminum alloy. We can use iron platinum alloy, gold cadmium alloy. But no market ready products with SMAs have been developed for use in architecture yet, and you can see that it's a new topic. It has not been يعني in frequent use yet. بعد في مجال كتير لحتى نعمل innovation in architecture using these shape memory alloys, and this is يعني limited only by the human imagination and also to satisfy some needs. The following alloys are among those of interest in architecture. So nitinol and copper zinc aluminum shape memory alloys are of great interest in architecture, maybe in the future. They have some advantages but also some disadvantages. بالنسبة للadvantages of nitinol, they are present in the market, they can be made in large quantities, they are يعني they have been they have been used for many years, they were يعني experienced for many years, they have a wide range of applications, they have a strong shape memory effect. They have a better tensile strength and elongation at break compared with other SMAs. هنا عم نحكي عن advantage of the nitinol over the others shape memory alloys. Specific properties can be achieved by additional alloy elements. We can add other elements other than nickel and titanium to this alloy, and it can also be supplied in small quantities. The disadvantages are the cost. بينما the most important disadvantage of copper zinc aluminum shape memory alloy is that it has a weaker shape memory effect, a weaker shape memory effect compared to, for example, nitinol. It has poorer tensile strength and elongation at break compared with nickel titanium alloys. يعني nickel titanium they seem to be more important. Okay, let's now talk about another type of properties changing materials, smart materials, the electroactive materials.